mathematicians, and get ready as today we work on solving word problems involving the volume of rectangular prisms with whole numbers. That's just a fancy way of saying we're going to be solving for volume of rectangles with a whole number on the side. Let's get into it with our I will statements.
Remember, your I will statements are your goals for this lesson. They are what we are trying to work on and learn more about throughout our time together today. As we continue on in our lesson, make sure you have your mind focused on these three things and showing them to your teacher. I will read the I will statement first, and then we will read it again a second time together. Make sure you're reading it nice and loudly so I can hear you, but no shouting necessary.
Listen as I read the first I will statement. Make sure to follow along with me. I will describe the effect on volume when a dimension or multiple is changed. Read that one with me nice and slow. I will describe the effect on volume when a dimension or multiple is changed. Let's look at the second one. I will define volume. Read that one with me. I will define volume. And our last one. I will solve for volume. Read that one with me nice and loud. I will solve for volume. Nice job, mathematicians. You're going to need your personal whiteboard for this activity. You don't need to draw any of the shapes on your whiteboard, but you will need to write a few things on your whiteboard. Once you have grabbed your whiteboard, we want to write the formula for finding volume of a rectangular prism. On your whiteboards, we want to write V equals L times W times H. Remember, those letters stand for volume equals length times width times height. Write that on your whiteboards now and pause the video. Now that you have it on your whiteboards, read it with me. Read it as what the letters represent. Listen to me first, and then we'll read it together. Volume equals length times width times height. Say that with me. Volume equals length times width times height. Now that we reviewed the formula, let's look at the specific prism I have on the board here. Remember, you don't have to draw these, so just use your eyeballs and look for now. In this rectangular prism, we have a length of 5 centimeters, a width of 6 centimeters, and a height of 2 centimeters. Since we know that information based off of just looking at our picture, let's write the multiplication sentence using these numbers. Our multiplication sentence would be 5 times 6 times 2. I want you to solve for volume on your whiteboards now. Once you have solved or multiplied these three numbers together, come back and play the video to see if you got the right answer. Did you multiply those numbers together and get 60? If so, give yourself a high five. Nice job, mathematicians. Remember, when finding volume, you're multiplying each of the sides together, and then you need to include your label as well. Because this image had centimeters, we know that we have 60 cubic centimeters as our answer. We can't forget that label. It's not just 60. We have to make sure we look at 60 what? I'm going to give you 4 more rectangular prisms to find the volume of. It is your job on your whiteboards to solve for the volume of these shapes. Once you are done, review them as a class and see if you agree with any of your classmates, or maybe we made a small multiplication mistake, which always happens. I will show you the shapes now. Above other 4 rectangular prisms, you are in charge of finding the volume for. Make sure you look at the labels carefully. And remember, you don't have to draw the actual rectangular prism, but make sure you identify which one you are solving for. Once you have finished solving, review the answers as a class, and then come back and we'll start our problem set for today. All right, mathematicians, for our activity today, you're going to need your problem set for lesson 7, a pencil, and if you have a highlighter, grab one of those now. Once you have your materials, come back. For our first problem, we are going to read it all the way through together. Then I'll explain what we'll do the second time we read through it. Let's look at it together. Jeffrey's first planter is 8 feet long and 2 feet wide. The container is filled with soil to a height of 3 feet in the planter. What is the volume of soil in the planter? Explain your work using a diagram. So in this problem, we're given different information about Gregory. Let's go through and highlight the different information we are given about Gregory now. We know that Gregory has a planter that is 8 feet long and 2 feet wide. We also know that it is filled. Remember when we see words like filled, that definitely tells us we're working with volume. Since the container is filled with soil, the soil has a height of 3 feet inside the container. Let's write that down as well. The question we're being asked is, what is the volume of soil in the planter? And we must explain using a diagram. Now we found out a little bit more information. I think our diagram is definitely going to be about what this problem is talking about, Jeffrey's first planter. So let's draw that planter now. For the planter, I am going to draw a rectangle on the top and some lines down the side. Our rectangles don't have to be perfect, or our rectangular prisms don't have to be perfect. Remember, this isn't art class. We know that inside of Jeffrey's planter, he has some soil. So I'm just going to draw a line going around to like here. So this is all filled with soil inside his planter. Pause the video and draw your planters now. Come back when you have finished. Now that we drew our planter, we can even label if you want inside that this is soil, so we remember. We can label the dimensions that we found in our problem when we read it the second time through. We know that the planter, or the box with the soil is in, is 8 feet long. Let's label this side our 8 feet. Don't forget the label. It's 8 feet long and 2 feet wide. Now that's already giving us some information that is going to help us later when we need to find the volume. We are missing a dimension, and that's volume. We don't know the exact volume or the exact height of the container, but that's not what it's asking us. It's asking us to find the volume of the soil in the planter. So we have to look back in our problem and see how high the soil is in the box. The soil has a height of 3 feet. We were given that information in our problem. Let's add 3 feet on the side for our soil. Now, we just practiced with volume in our warm-up problems, so we should remember the formula. If not, let's write it again at the top of our paper. Since we're trying to find volume of the soil, we have to have V for volume equals the length times the width times the height. Now that we have our formula up here and we have a picture to help us, let's fill in the information we know. In the problem, we were given the length, the width, and the height. Let's add that in. So our length was 8 feet times the width, which was 2 feet, times the height, which is 3 feet. Now we have a formula to solve for volume. Let's use this formula to help find the number of cubic feet of soil in our box. So if we were to multiply this, 8 times 2 is 16. 16 times 3 is 48. So I'll draw that in a little bit darker so we can see our work. So the volume equals 48, but we can't forget our label, 48 feet or cubic feet. Now that we have our picture, we drew out our work mathematically, let's write one final statement to show what this 48 cubic feet is representing. So the 48 cubic feet is representing the soil in the planter. So we're going to say there is 48 cubic feet of soil in the planter. It's important when we go through different word problems that we take the time to go through and read the question more than once, pull out important information, and look for exactly what they're asking us. Then we can take what we have found in the problem to help us draw a picture, collect our mathematical thinking, and then share a final statement that includes our answer in it. You guys will continue to work on your problem set problems, a few more as a class, and then independently or with a partner. Take your time, mathematicians, and make sure that your picture doesn't have to be necessarily perfect, but you want to make sure that it represents what is being asked in your problem. Good luck, mathematicians, and I'll see you guys soon. Bye.